In this circuit diagram, we need to find the Thévenin equivalent circuit with respect to the terminals A and B for the circuit. Terminals A and B are located right here. We need to find voltage and resistance. The Thévenin equivalent circuit is going to look like this. We're going to have our voltage here. It's going to be a plus minus. And then we are going to have a resistor up top here. This is going to be our RTH. And then we're going to have our terminals A and B out here. First thing that I like to solve for is resistance. It always seems easiest to me. So what we can do is see that this resistor and this resistor are in parallel, and this is in series with that parallel resistor. So we're going to use the formula for parallel resistors in combination with the formula for resistance in series. We have 1 over our first resistor plus 1 divided by our second resistor. This is all being raised to the negative first power, and then we can add 2 since it is in series, and we get 6 from this. So our resistance is 6 ohms. Now we need to find VTH. We need to find the voltage. The voltage is going to be going across our A and B terminals, and we need to find what that is. There's a couple different ways we can do this. One I like to do, what looks good here, would be a node voltage analysis. We learned about this earlier in the chapter, where basically we pick 2 nodes, this one and this one. I'll pick these 2, and then we set up a current formula and then find the voltage. So this is going to be our plus minus V1, and then this is going to be our plus minus V2. Now we need to find VT of H. However, if we had a voltage right here, we could see that it is in parallel with our VT of H. So our V2 is basically going to be our VT of H. So we can start solving this now. Our 12 volts is our voltage source. To start this, we are going to have our V1 minus the source voltage, because our V1 is going out of our node and our source voltage is going into the node. We know our source voltage to be 12 volts, so we're just going to plug this in straight right here. And this is happening over the 12 ohm resistor, so we're putting this all over the 12 ohm resistor. Next, we're going to handle the actual V1 itself, so we will have a plus V1 over 6 ohms of resistance, and then we have this V2 going out of it, V1 minus our V2, and this is all over the 2 ohm resistor. Now we have 2 unknowns here. We have V1 and V2. Also, this is set equal to 0 because of Ch.4's voltage law, but we have the V1 unknown and the V2 unknown. So we need to find this. We're going to use the second node to do this. We're going to have a V2 minus our V1, and this is all over the 2 ohm resistor, kind of redoing the first step, but for our second node. And then we're going to have a plus. Normally we would have a V2 over resistance. However, this voltage is not actually here, so we aren't going to do anything with that. We can see that there's nothing here. What we are going to look at after we've looked at this part is this 8 amps right here coming into our node. We know that anything coming into a node is negative, so we're actually going to take that positive away and make it a minus, and this is 8 amps set equal to 0. We can find our V2 or V1 and say that our V2 minus our V1 is equal to, bring 8 over to the other side, and this is 16 volts. Now we want to solve for V2 because our V2 is equivalent to VT of H. However, we have a lot of V1s in our first equation, so we're just going to solve for V1 and then plug in this V1 into this equation. We're going to come back to here and get our V2. So I'm going to quickly rewrite this as V2 is equal to 16 volts plus V1, and now we can plug this in here. We're going to factor out a few things. First, I'm going to factor out our V1 and combine everything with the V1. We know if we do this, we're going to have 1 over 12, and then we have another V1 in the middle. This is going to be a plus 2 over 12. We're dealing with this one right here. Next, we are going to deal with the V1 here. We have a plus V1 over 2 ohms. So we're going to have a plus 6 over 12. And then outside of our parentheses, we have a 1 over ohms because we can factor that out. After this, we are going to look at this 12 ohms, or I'm sorry, this 12 volts over 12 ohms. We're going to have a minus 1 amps. And then we have a minus V2 over 2. Well, we know what our V2 is. We know that our V2 is 16 volts plus volts 1. So we're actually going to have 16 volts over 2. If we factor in the negative, we're going to have a negative V1 over 2 as well, and this is set equal to 0. I'm going to combine all of the V1s. So if I want to add this V1 right here in with the others, I'm going to multiply the top and bottom by 6. So I'll have 6 over 12, that way the denominator is the same. Adding all of these three, we're going to get a 9 over 12. So 9 over 12 minus 6 over 12 is going to give us a V1 times 3 over 12. And then from this, we're going to get a negative 8 volts. However, I made a mistake right here. This 2 that it's over should be in ohms. So instead of being a negative 8 volts, this should be negative 8 amps. We can add the negative 1 and negative 8 amps together and move it to the right side. This is going to be set equal to 9. And we're going to get that our V1 is equal to 36 volts. However, this is not what we want, because this solves for this right here. But this is not the resistance that's right next to our VTH, or equivalent to our VTH. Our V2 is that. So we need to plug this back in. We are going to have that our V2 is equal to 16 volts plus our V1, which is 36 volts. If we do this, we're going to see that our V2 is equal to 52 volts. And since they are equivalent, we can say that 52 volts is our VT of H. That's how you solve this problem. If you want more introduction to circuit analysis problems, they will be linked in the description below, as well as notes that'll help study for this material or exams.